Welcome back to this course, Introduction to the Java Programming Language. This is a presentation of Coding Boot Camps. This session is Session 2, Application Development Fundamentals. In our previous session, we discussed computer architecture. We discussed the several different tiers or several different structures or architectures of applications. We also talked about the Java virtual machine and how that actually is able to map hardware for us behind the scenes so the Java programmer doesn't really have to worry too much, if at all, about the hardware. And we also talked about installation of your integrated development environment. So in this session, we're going to learn about the structure of Java programming, learn about memory concepts, learn about fundamental data type declarations, learn about fundamental I/O concepts, and learn about fundamental operators, and then we're going to build our first program. So the materials so far are just these learning materials, these slides, and you can reference the solutions to the programming exercises as well. So in this session, we're going to take a look at some terminology. So a package in Java, a class in Java, data members, user-defined methods, and block statements. So a package in Java, it's a special term. Yes, it is a container. It says here it's a container. Inside the container are actually the classes, the interfaces, which is like a structure, an abstraction of a class, and then other packages. So packages are, they are implemented physically as a folder. So just like a folder can have files and other folders, same thing here. So our packages will have our class files. They'll have our interfaces, which will also be files, and then other packages which are physically implemented as folders. And then these sub packages are again the same thing. They are just they just have parents of other packages. And we'll see here there are libraries that pre-existing packages that we actually import to our application, so we don't have to go and recreate some of the functionality that is included in these libraries. Very, very similar to header files in C++. So a class, well, it's definitely a keyword, and a class is actually a user-defined data type, and it is meant to, in almost all cases, model a real-world object. So the behaviors and the properties are implemented by what we call methods and what we call properties. And the properties are different data types. Can be say it's age. Age would be an integer. It can be your address, which could be a string. And we can see here that the header for a class. So classes will have headers declaring them, and they will also have code blocks. So our data members are those properties for the class, and they are again modeling the attributes or the properties of that real-world object. So here in our example, it looks like we are modeling, say, a student object, and in our case, we are interested in the student's age, which is an integer, student's name, and the student's GPA. And these are all different data types, as you can see. And then there are user-defined methods. So methods are little code blocks that implement some kind of functionality for the class. So for our student here, we know we have that age in there. We may want to output that age. So we've captured that data, and now we want to output it. So we will call this method within the student class. Calculate GPA. So we'll have that data, and within the student class, we'll want to calculate the GPA, and then get course schedule again will be that little functionality which is part of that student class. Now a student can be modeled in different ways. So the model is very much driven by the business that we're working with. And block statements represent those lines of code that are called in the user-defined method. So we can see here, here's one example of a block statement that would be part of those user-defined methods that are part of a class. Here we are building our class structure. So again, we have our header, and these curly braces here represent the class. And then we have a method in this case called the main method. And we'll talk a lot about the main method. You can see here some comments, and comments are ignored by the Java compiler. They are just for programmers. And you can see here our code block here. So we have our class, and then we have our method. We don't have any properties in this particular class, at least not yet. So let's take a step back and take a look at some of the items that we talked about. Number one, let's look up here. We see here in this class file, this is actually a class file, we are referencing our package, and this has to be here. So Java will strictly enforce the relative path or the class path for the class that we're working on. So our package is scanit, and if we look over here, we can see that scanit is implemented as a folder. And we can also see it down here as well. We have our class header here. And if we start to look down here, we can see some user-defined methods. And then we have our main method. So, and if we look a little closer here, we haven't, we'll talk about this shortly. We can see here that we have some code that in design time or compile time compiles fine. So we can see here we have 1 divided by this integer dem. And as we call it down here, it's called diver. We're passing in a 1 here, and that's perfectly legitimate, not a problem at all. If we look a little further at this class and take a look again at the physical file system, we can see that this class, scanner console, is physically implemented as a file, a text file with the extension Java, and it's living here in our scanit package or our scanit folder. So if we take a little closer look here at runtime, because we talked about the difference between compile time, design time, and runtime, now we have runtime, so we can see that this application is actually executing. However, in this case, we have put a 0 in for our dem integer, which again would compile fine, but actually during runtime, it's going to return a runtime error. So the moral of the story here is just because your application compiles does not mean that you won't have errors during runtime. So again, Java is, just like every other computer language, using the memory of whatever machine that you're on. The JVM does a lot of the hardware management, if not all of the hardware management for us. Java gives us several what we call primitive or basic types. These are out-of-the-box basic types. We have our float, which you can see here is a decimal point. Integer, which has no decimal points at all. Our double, which has this type of precision here, different from a float. A float has a higher precision. What we call a string, which is characters here, which are just really printed to the screen, however you can compare the two. A Boolean, which is a true or false, a char data type, which is 1 character, and then a byte. So all of these are mapped to the JVM, and then the JVM takes care of it for us as far as putting these variables, these data types in memory, so we don't have to be concerned with it. Java is a very strongly typed language, so every variable requires some kind of a data type. And these data types actually help us with efficiency. So all of these here you could see require different sizes of memory. And this actually makes the memory more efficient and the running of our program more efficient. So local variables can be declared within methods. They must be declared and initialized before they are used. Class and instance variables can be declared anywhere and initialized to defaults. So initialization is always big. We have to think about when we are modeling real-world objects, when we want to initialize and what the initialization should be. Every object has some kind of a beginning state. Multiple variables of the same type can be declared on a single line. So you could see here, instead of int I and then another line int j and then another line int k, we're saying int ijk right here in a single line, which can make the somebody else looking at our program can make it easier to read, certainly. Let's talk a little about I/O, or input-output concepts. So there is a library or a package that contains all of what we need in order to do input-output from an external source, such as the keyboard, such as the monitor, or the console, or such as files. And that could be opening a file and reading from it, or opening a file and reading to it. So all these streams represent some kind of an input source, such as the keyboard, such as a file, or an output destination, such as the console or the monitor, or a file. And a stream, in this case, is defined as a sequence of data. There are input streams and there are output streams. And we can see here again the source, the program, and the destination. So if this is the keyboard, we have the program which is taking the data from the source, and then it's processing that data from the keyboard and then either outputting it or using it in some kind of calculation, eventually outputting it in most cases. Java byte streams are used to perform the output of 8-bit bytes. So again, this is a specialized type of functionality. Most frequent classes used are file input stream. So this is actually a class that the I/O library gives us. So there's file input stream and file output stream. And let's take a look here. So we can see we're importing Java I/O, which gives us essentially packages of reusable classes. You can see here we're declaring our type here, CIN, as input stream. And because we may get something from the keyboard which is error, right? We could pass in something invalid from the keyboard. We use this try so we can handle the error. We'll talk a little bit about that in upcoming lessons. But you can see here we do the input stream, and in this case we're taking characters in from the keyboard, and we're actually instantiating this new keyword. Means we're taking input stream and then we're creating a specific input stream that we're calling CIN. And CIN goes into its own section of memory. We're outputting some instructions to the user, and we're making our declaration. And here we're actually reading from CIN. We're doing what's called a cast here. So we're taking whatever's coming in, we're casting it as a character, and then we're going to output it again right away. Back to the console, and we're using what's called a do-while loop or do-while block here. You can see here that we have a block, and then a condition is evaluated. Well, was the character a small q? If not, keep going. That's what that's saying there. And then there's a finally here where we actually close the variable, so we take it out of that memory that it's in. And here's the output from what we just saw. Right here, so our characters, as long as we don't have Q, we can go through whatever character we put in, Java will output that character back to the console. Let's take a quick look here at our operators. So the operators are really exactly the same as they are with C++ or .NET. In this case, if we say that uppercase A equals 10 and uppercase B equals 20, you can see here the plus. So if we add them, it gives us 30. If we subtract A from B, we get, in this case, negative 10. Be careful, make sure you see that. If we multiply these two, we get 200. If we divide it this way, B divided by A, we'll get 2 back. Now this is the modulus, sometimes called modulo, actually does division, but the output of modulo returns the remainder. And that's useful a lot of times if you want to test for a zero remainder. If it's a zero remainder like this, they are multiples of one another. But if a remainder is returned, we can actually do a lot with that. There's a few ways to increment, few ways to decrement. You might see it done different ways, but in this case, there are either the plus is either on the right or the left. Sometimes the way you structure your program, you may have to put it on the right, and other times you have to put it on the left. Try not to be too concerned with that. You may just have to test it and make sure that it's working as expected. But you can see here the whole idea with increment and decrement is to either increase by 1 or decrease by 1. And this is really useful because when we're looping through and we want to count how many loops we iterate through. And here is where we're testing certain conditions for true or false. So again, we have our uppercase A equals 10, uppercase B equals 20. The double equals here means equal to. I know it says double equals because single equals is assignment, so our double equals. So they're not equal, so this will return false. A is not equal to B, right? That's not equal, so that returns true. A is not greater than B, so that returns false. A is less than B, that is true, so it'll return true. And a lot of times these comparators are used in if statements. They could be used in other types of structures, but you'll see them almost always used in if statements. A is greater than or equal to B returns false, and A is less than or equal to B returns true. So here we're going to create a program by typing it into the text editor. Hopefully you have Eclipse already downloaded and set up. But before that, we're going to take a look at just using Java through the command window. So this is not really done all that much, just really done in teaching. The command for Java to compile a Java application. So notice we have remember our class file is a file that with an extension .java. We call Java-C on it, and that compiles it. And then to execute it, we type Java space, and notice no extension here because it creates a class file, and we don't use the class extension on the class file. And a class file is actually the compiled version of our of the class of our source code class. So when we create our Java program here, we need an editor, whether it's Eclipse or whether it's just a simple text editor. We have to start with our class header, and then we have our main method again that does something. And we can see here this is outputting hello world. Then we compile that class by calling Java-C on the class that we just built. So we just saved it. We opened a file. We entered that code. We named it hello world.java. Now we'll run Java-C. And after we create Java-C, another file is created by Java that gives it the class extension. So .class. So the word class is used quite a bit. And then to actually run it, we omit the class extension and we say Java hello world, and that will actually execute the program that we just wrote. So you can see here what we're doing here is there is a hello world.class file that was created, and we're getting the output right here. So what we want to do here is we want to write a program that prints hello world 10 times. There's a few different ways to do that. And then we want to write a program that shows the understanding of all operator types. Let's take a quick look at that after we complete our summary. So here we learned about the structure of Java. We learned about memory concepts. We talked about fundamentals of data type declarations. We talked about some fundamental input-output or I/O concepts, and then we learned about fundamental operators to make our first program. Again, check your learning materials, and there are private tutoring sessions available. And thank you for watching this video. before we conclude, let's take a look at our lab, our upcoming lab. So hello world 10 times. Well, if you remember from our lecture, we use the do while loop. And what we have to do is we have to start off with an initialized variable. In this case, I picked I equal to 0. And then what we do is we go to the do while. The block actually outputs hello world. Then it increments I. And our condition here is going to be while I is less than 10. So you can see every time we execute the do block, I goes up by 1. And the output from this is going to be, it's going to print hello world 10 times. Another way to do that is right here. We can just simply use the system.out.println hello world. That works also. Run as Java application, and that does the same thing. And for our operators here, what we are doing here is we just like we saw in the lecture, capital A, integer capital A equals 10, integer capital B equals 20, and then we're outputting adding the 2, subtracting the 2, multiplying the 2, dividing the 2, modulo, and then we do our increment and decrement. One thing about increment and decrement is increment and decrement actually changes the value in memory. So if coming down here, all we were doing was outputting the operation, A and B retained their value. Here though, notice B is the only operator. We're actually incrementing it now to 21. So that means when it comes to the next, to the decrement, it's going to start from 21 and then go down. So that's why we reset the value of B right here in order for this to work as expected. So just something to be, when you increment and decrement, you actually do change the value of the variable in memory. So please go ahead and complete the lab and stay tuned for the next presentation.